Hello and welcome to Chapter 3-6, Compound Inequalities. A really cool topic, I think. It's somewhat complicated and you're going to have to spend some time studying it to understand it. Put your name on your notes as well as your hour and date. And the first word we're going to talk about is just what a compound inequality is. And here it is for you. Definition, you can go ahead and jot down. Definition of a compound inequality. Basically what it does is it consists of two distinct inequalities joined by the words and or the word or. Two inequalities joined by the words and or the word or. So again, hit pause as we go through here if I get ahead of where you are to make sure you understand things. Please do that. Let's look at first of all, what an and compound inequality might look like. All right, well, let's say I had a condition where I said, okay, x is less than or equal to 3, and x is greater than -2. All right, well, that's compound because there's two conditions that have to be met for me to find a value for x. Okay, so like, can you think of a number that's less than 3 and greater than -2? Well, there's a lot if you include all the decimals, but you could say 0. Right? 0 is less than 3 and 0 is greater than -2. How about, I don't know, 1? 1 is less than or equal to 3 and it's greater than -2. So there is another notation for this you're going to have to be aware of. Since -2 is kind of that lower boundary, I could write this like this, -2. Now I'm going to switch the sign here. -2 is less than x, because if x were 0, right, it would be less than x. And since I'm talking about the same x here and the same x here, that is the number we're talking about. This x is also less than or equal to 3. Okay, so if you see notation like this, and you're going to need to recognize it and sometimes leave your answers this way, this is an and compound inequality here, because what it's saying is that basically x has to be in between -2 and 3. Okay, -2, just listen to it. -2 is less than x, and x is less than or equal to 3. So what we would say here, if I asked you to read this, you would just say -2 is less than x is less than 3. Okay, which means essentially that x is between -2 and -3. Oh, I'm sorry, -2 and +3. Sorry about that. That's +3. Sloppy one there. Okay, now the other type of inequality, so that's and the other one is an or condition. Okay, so this might look like, oh, let's say it might say x is, now this is kind of a different one here, so you might do a little separation here, although it's still a compound inequality here, so I don't want that line to cross your whole thing. So and is one type, 2 is or is the other type of compound inequality, and this might say x, let's say, is less than -2, or x is greater than or equal to 1. Now again, that's just an example here, and this is really the only way to write an or compound inequality is actually with the word or on your paper. So you're going to have answers that could be written this way, or an answer that could be written this way, depending on which type of inequality it is that you're working with. Okay, so those are compound inequalities there. They have two conditions joined by the word and or. Okay, well, let's look at an example. Okay, and if you get lost on this particular one or need some extra help, I believe if you look on page 201, I can't remember if this is the exact one on page 201 or one very similar to it, but it's the one I'm using for my notes. So copy this down here. You should be on the same page, really. You should still be on this page, I hope. I just need to go to a new page to make it easier for me to write my notes for you there. So you just start right there, jot this down. Graph all real numbers greater than -2 and less than 6. Okay, again, you can see that on page 201. So this is a compound inequality here. Well, let's first of all make sure we understand what they're asking. You basically have x is greater than or equal to -2 and x is less than 6. Now the purpose of this is to make sure you understand how to graph it, because it's a little trickier. At least it looks weirder at the end here after you've graphed it. So now since it's joined by the word and, remember we can rewrite this. Since this -2 is the lower boundary, I'm going to put -2 first is less than or equal to x, which is less than 6. Okay, so this is the same thing. These two things are the same thing. This is the one that you know, we would eventually like answers to be written when you are doing the work here. But this is just another way that this question is being asked here. Okay, in the middle we're going to work it out. But before I do the graph, which is what it's asking for, the graph, which I haven't done that yet, right? Let's go over here and let's make a note on some things that you need to do. Okay, so in graphing a compound inequality, the first thing I'd like you to do is to mark the boundaries. In other words, where does the graph begin on the two conditions here? So in the middle here, what I'd like you to do is draw a line. Put arrows on it, it's going to be a number line. Now in this particular example, it says that x is greater than -2. So that means I have a boundary here at -2. And then it also says x is less than 6. So I've got a boundary over here at 6. I really like to put 0 in there just so we have a little bit of perspective on there. I think that's helpful for us. So here again is another way that we would write this. Okay, so let's just look at this first condition here. Okay, so after I mark the boundaries, the next thing I should do is graph one of the inequalities. You probably have a little more room on your paper. So I'm going to start with x is greater than or equal to -2. Now when you're graphing it, you can think about this one right here if this one is more confusing. You have to graph x is greater than or equal to -2. So we're going to mark the boundaries. We've got -2 and 6. We're going to graph it. Well, that's a closed circle, right? Closed circle on -2. That's a boundary. And it says numbers greater than -2. Right there again, I'm still looking at that point. Numbers greater than -2 are this way. So basically this first condition suggests all numbers that go that way on the number line. Okay, now I've got that part. Now the next thing I need to do is graph the second, which is x is less than 6. Okay, now that is an open circle. Again, review from the last video. It's an open circle because I don't have an or equal to sign. So I'm going to do open circle here on 6. Make it clear that that's open. And I want values less than 6, which are this way here. Now, since it says the word and, both of these conditions have to be true. So for this graph over here that's going this way, if I pass 6, that doesn't count because it has to also be true of numbers less than 6. So essentially, I have a graph going this way, and I have a graph going this way. So the only numbers that are going to actually be solutions are going to be this area in between the two numbers. Numbers greater than -2, sorry, and less than 6. I'm going to get rid of, whoops, I didn't mean to erase all that. I'll put it back here. Just getting rid of that arrow above. Okay, we've got that. So basically this area right here represents values. If you have x here, okay, this represents values of x. It's less than 6, and -2 is less than or equal to x. And there you can see the inequality. So that is what an and inequality typically looks like, because two conditions are true here. So let's do a dotted line here that hopefully helps you see what's going on with those. Again, you can review page 201 for a little more information on that, and I suggest you do if you're confused by this. And we'll get started at looking at what an OR inequality looks like here in the next video.